Our last section in chapter 5, it's going to be 5.8. I can factor linear expressions, and I apologize because my work is kind of bleeding through. First thing we need to do is make a list of prime numbers because we're going to use this later. And prime numbers are numbers that can only be divided by 1 and themselves. 1 does not count, so 2 is the lowest prime number, 3 is prime, 5 is prime, 7 is prime, 9 is not going to be divided by 3 evenly. 11 is prime though, 17 is prime, 19 is prime, 23 is prime, 29 is prime, 31 is prime. There are infinity more, but we're going to stop there. That will be enough for us to use today. So the first kinds of problems you're going to have are going to say to find the greatest common factor. So let's put here find the, and it's usually just going to say GCF, greatest common factor, of, then it'll give you two monomials, so that means two expressions with only one term. So maybe we'll have to find the greatest common factor of, let's say, 14x and 49. So first thing you have to do is you have to factor both of these into their prime factors. So you're going to make a factor tree, and I'm going to think of any two numbers that multiply together to be 14. And I know 2 times 7 is 14. And I'm going to circle all the ones that are prime. Oh, those are both prime, so I'm done. Then I need to find any two factors of 49. 7 and 7 are both factors of 49. They're both prime, so I'm circling them and I'm done. I only stop making a factor tree when I have all prime numbers, and I do here. Then I'm going to write out all of the factors of 14x and 49, all the prime factors, and you have to do it this way. So I'm going to write 14x, which is from smallest to biggest, 2 times 7 times I also need an x, which doesn't show up in my factor tree. And then 49 is 7 times 7. I'm going to circle any of them that match. Okay, we have a match right here. We have a 7 on top and a 7 on bottom. That means the greatest common factor of 14x and 49 is 7. So my answer to this problem would be 7. The greatest common factor between 14x and 49 is 7. Let's do one that's a little bit more complicated. So let's say find the greatest common factor I don't know why I'm writing it out this time. The greatest common factor, or GCF, of, let's do 36x and let's do 81xy. So I have 36x and 81xy. I need to make a factor tree for both of these. So I have 36x. I make a factor tree for this. I think of any two numbers that multiply to be 36, and I'm going to choose 9 and 4. You could have also done 6 and 6. Neither of these are prime. They're both composites. I'm going to keep going. What can multiply together to be 9? And that would be 3 and 3. Those are prime, so I circle them, and I know I'm done. I say what can multiply together to be 4? 2 times 2. Those are prime, so I'm done. Then I have to also do 81xy. I need to factor that. I need two numbers that multiply together to be 81. That would be 9 times 9. Those are both composites, so I have to keep going. What multiplies to be 9? I could do 3 and 3. Okay, now I need to write it out like I did here, where they're above each other. So I'm going to put 36x, which is from smallest to biggest, 2 times 2 times 3 times 3 times x. Don't forget the x, even though it doesn't show up in your factor tree. And then 81xy is 3 times 3 times 3 times 3 times x times y. And I'm going to look for my matches. These are a match, these are a match, and these are a match. I multiply one of all of my matches together. So I'm going to do 3 times x. 3 times 3 is 9. 9 times x is 9x, so 9x is my greatest common factor of 36x and 81xy. Some of your other